Hello, Georgi Romanic here again. Today we are continuing exploring Coriolis force and we are answering part B of the question that I introduced in the previous video, and that is, now you see it on your screens. That is fairly simple demonstration. Change of work dA, A is usually a letter that we use to denote work. From classical physics, you know it is F dot dr, where F is force that is changing position vector by the amount, infinitesimal amount, dr. R is position vector that is changed due to the action of the force. Well, our force is Coriolis force. And that force is negative 2m, m is mass of the object, omega cross v. So that means that dA is equal minus 2m omega cross v dot dr. By the way, I hope you can immediately see that work is scalar because we have dot product between two vectors over here. But dr is really v dt. So that means that dA is equal negative 2m omega cross v dot v dt. This is a cross product between two vectors. And cross product is cross product gives us result that is a vector perpendicular to both of these vectors. And then we take, so this vector is perpendicular to both omega and v, and then that vector is dotted with v, and that dot product has to be 0 because dot product between perpendicular vectors is 0. Namely, what I'm saying is that omega cross v is perpendicular to v. Perpendicular means angle between omega cross v and v is 90 degrees. So that means if we do actually dot product between these two, I will have omega cross v dot v to be equal intensity of this vector times intensity of this vector times cosine of 90 degrees. Angle times cosine of the angle between these two vectors, and angle is 90 degrees, and cosine of 90 degrees is 0. So this whole term is 0, regardless of the intensity of these vectors. And that means that this over here is 0, and that means Coriolis force does no work. Until next video, goodbye.